Alright everyone, welcome to my YouTube channel Coded. Here today we're going to be doing hands-on examples where we're going to use control structures, we're going to use data structures, and I'm going to be showing you everything we did not learn during the previous tutorials. So if you haven't watched the previous tutorials and you're new to what control structures are as well as data structures, you might want to watch the previous videos. I'm going to link them below just in case you want to watch them. So we have a question here which says bank ATM transaction. Write an algorithm for the main ATM loop. Present a menu, withdraw, deposit, and check balance. Perform the selected operation and loop back to the menu until the user selects exit. Use the repeat until and the case selection. Case selection is simply our classic if-else statement. So the whole idea is we are trying to develop the ATM machine or something similar to that. It means we're going to need two variables, integers. The first variable is going to hold the account balance, so we'll call it account balance. The second variable is going to be the amount, like the amount of money the user is willing to withdraw or willing to deposit into their account. And the next variable we're going to need is the action. What action does the user want to perform? Is it a deposit, withdraw, is it a check balance? And we are going to need the user's password. We're going to need a variable to store the user's password, and I believe here we would use a constant. Normally, like this, we are just working based on the assumption that the user already has an account, and if the user has an account, he has a default password which is being stored in the system. So I believe here is a perfect example for us to use a constant. So without any wastage of our times, we are going to dive right into writing the algorithm. Algorithm keyword, name of the algorithm, bank ATM. We're going to need, we are also going to want to use a procedure to tell, a procedure to tell the user exactly what our platform can do, because unless we tell them what it does, I feel like the user won't be able to figure it out. And we're going to be using a procedure because we want to use this block of code over and over without having to write it by ourselves. So the action is like the action the user wants to carry out. String. We are also going to need pass, the user's password. Before anything happens, we want to check if he has the password right. We want to do a small authentication test. So we're going to call our procedure help, like help the user understand what our platform does. So here we are going to write exit, like he should enter exit to quit program or program session. Deposit, to make a deposit. Withdraw, to make a withdrawal. Then we want to end. So we want to begin our algorithm itself. So somewhere around here, the begin keyword. Now immediately we begin our algorithm, the first thing we want to do is display the help menu, which will tell the user how to use our platform. Now in our repeat loop, well, repeat loop because the program said use repeat loop, but we could always use a while loop. While loop would work, but a repeat loop is convenient. So we want the user to enter the operation he wishes to carry out on our platform after telling him the operation. The next thing we want to do is we want to read this action. Now we want to check if action, the action the user entered, is equals to deposit as we set it up here. Deposit. So we see that since deposit is a string, since the actions are string, this is a string, so this is being put in quotes. Then we want to write, we want to ask him the amount he wishes to deposit. Well, I don't think ATM machines like do deposits, but well, that's just me reflecting. But do they? Do tell me in the comments. Now we want to modify the account balance. We set the account balance, that is, if once we have taken the amount, if it is a deposit, we want him to input the amount he wants to deposit. Then we modify the original amount to balance plus amount. Now just below the else, just below the if, we have an else if action else if action equal to withdraw. In quotes, don't forget. Then we want to ask the user to enter password. We want to read the pass. The variable assigned for password was pass. Now we want to check if pass equal to, oh my bad, I didn't create like the constant. So let's create the constant keyword, and we want to write the constant name, that is let's call it account pass. This is so inefficient, but and we want to set it to code it. Well, that, yes, the error is on my part, so you want to modify that. So if pass is equals to account pass, then we want to ask the user to enter the amount, right? Enter amount. Now we want to check one more thing. If the amount is greater than the account deposit, or the account balance, sorry, then we want to display an error message, or we want to tell the person in, sorry, insufficient funds. Insufficient fund. Else simply means the inverse, like the amount is less than or equals to account balance. We want to modify account balance because the person has authentified himself using his password. So we want to modify account balance. Don't forget the underscore. We set it to be equals to account balance minus, we set it to be equals to account balance minus amount. Then we want to display the new account balance, right? Your new balance is account balance. Now we want to, so this is the else we are working with. So else if action, oh sorry, action equaled check balance then we simply want to display the balance, so we will write your balance is account balance. And with that, we want to end our if and else sessions. So we want to end if, but there is a last condition we haven't verified yet on the new piece. Well, else if action equal exit. If the user enters exit, then we want to tell the user thanks, or something like thank you for using my platform. I don't know, I'm just going to end mine with a simple task. Else, well, there are some users which are very, very stubborn. So like you're going to tell them the platform can do this and this can do that, but there will be this user that will enter B or some random thing. And if any user enters some random thing, we want to remind the user what our platform does, and this procedure here tells us exactly, or tells the user exactly what our platform can do. So we see that using a procedure enables us to write this code on the screen as many times as we need without actually having to write it as a programmer. This is one of the advantages of using procedures and functions. So we want to end our if. Now we want to use until. Remember, we were using the repeat loop until exit. So once the condition here is exit, then the program comes to an end. So here, essentially, that is our program. So a recap of what our program does, like it has a procedure which stores the basic functionalities of the system. We used a repeat loop and we use cases exactly like the question demanded. We have first case where it is a deposit. We have the second case where it's a withdrawal, and if it is a withdrawal, we're going to need the password, and if the password is okay, we're going to check if the amount is greater than the amount, and if all of those things are correct, then we are going to redraw the money. We're going to redraw the money and we're going to display the account balance, else we are not going to do that. And the next thing is to check balance, where we simply display the account balance. And finally here, where we check if it is an exit, and if it is an exit, we tell the user thank you. And here we display the help function again for users who don't know what they want. And essentially our algorithm is lacking something very important, and I feel like I'm going to leave this for you guys to figure it out. Well, I believe everybody who tried figuring it out got it right. The algorithm is lacking the end keyword. We remember saying in one of the characteristics of an algorithm that it is finite. So without any wastage of time, we will go to the next question. And the next question is a simple sorting. Input a list of 5 distinct numbers. Here is an example where we have to use arrays. Write an algorithm to sort them in ascending order using a simple comparison and swapping logic. So I'm going to try my best to explain the logic to you guys, and it wouldn't be my fault if you do not understand, but I sure hope you do. So we would store our elements like this in an array, and let's say this is 1. Now it said ascending order, right? So this will be 7, and this will be 1, and this will be 3, and this will be 2. So we are going to use a for loop to go through this array. Now in the first iteration, we want to check if the number at this index, this is 1, we want to check if 1 is greater than the number at this next position. So we want to check if the number at I is greater than the number at I plus 1. So if the element at I plus 1 is less than the element at I, we want to swap their position. So we will need another variable. We will set this element here to be equals to this element here. So we'll store 1 in here, and we're going to move 7 into this position, and then we're going to move this into the position 7 originally held, and we're going to repeat this process for each and every element in the loop. I don't know if you got it, but I hope you get it as I write the program or the algorithm. I don't know, I keep on calling it program. So let's begin. Algorithm keyword. Remember, we need to have a clear idea of whatsoever we are trying to create. So first things first, we're going to need a for loop. So we'll need an index I. We're also going to need another index j for the second for loop, which will be searching this. And we're going to need an array, and we're going to need a temporary storage location. So let's define our variables. We're going to need I, j, and a. This will be integer. Then we're going to need an array. So let's just call it store 1 to 5. It's going to be an array of integer. Oh, sorry. Array of integer. Okay, good. That looks right. Now the next thing we want to do is begin our algorithm immediately. We want to ask the user to fill in the array for us, right? And the elements of array. And we want to use a for loop for I from 1 to 5 do. So we want to read these elements from our for loop. So read store at the index of I. So this will go on 5 times and our array will be full. And 4. Okay, that was the first part, us filling the loop. Now the exciting part begins. Now we want to compare the elements for I from 1 to from 1, sorry about that, to 5 do. Now for J from I plus 1, we remember the table, let's draw it here again. So this is I. So the first element is 7. So we want to take this first element. Now we want to take J. J will be this second element. And J is going to start where? I plus 1. This is I, means the next cell is going to be I plus 1. So we want J to start from I plus 1. And we want to compare this and this. So we want to say if J is less than I, or if the element at the index of J is less than the element at the index of I, then we want to modify the value. We could always still use one loop as we did here, and we can manipulate I plus 1 and I bird. Well, this is a convenient way and a more beginner friendly way. So from I plus 1 to 5 do. Now we are going to need an if statement. If the store at the index of I is less than the store at the index of J, then we want to modify the value. Then we are going to set the value at the index of J. We're going to set A to be equals to store at the index of J. So we are safe keeping this value and we are modifying the value. Oh, sorry, at the index of I. I'm sorry about that. We are safe keeping the value in the storage in the memory of I, and we are transferring the value at the memory of J to the memory of I. So we're going to say store at the index of who? I is equals to the store at the index of J. Once these elements have been swapped, now we want to say the store at the index of J is equals to A. So we see here that we are swapping the elements. That is a classical swap. And this is a simple sort. This is a simple bubble sort. So it just compares and compares and compares. And that's essentially it. And so we want to end the if, and we want to end the first 4, and we want to end the last 4. And one thing we want to do is we want to display the elements, right? So we will need another for loop for I from 1 to 5 do. Right, store at the index of I. And this is our new modified array. I feel like we should have written something like this is our new modified array somewhere here, or your sorted array. Your sorted array is, yeah, that will make it more comprehensive. And we want to end our 4. End 4, and we want to end our algorithm. And that's the end of our algorithm. We are going to do one last algorithm, then So this is the guess game. We're going to need two arrays, the CPU array and the player array. We're going to need, so the essence, I'll try to explain the code why I write. I'll try to explain the algorithm why I write it. I feel like I didn't speak about the character data type before, but if you've gotten this far, then you've learned a new data type. And I do remember saying I'm just going to be teaching some data types, so this just slipped my mind. And I didn't speak of the Boolean data types either. So this is going to be the win condition, and this is going to be the loss condition, and they are going to be integers. So the win condition will simply count the number of right guesses the user has, and the loss condition is going to count the number of wrong guesses the user has, and is going to tell us if the game is over or not. Now this is the array where the user's data is going to be stored in, and this is the array where the CPU's data is going to be stored in. So in essence, this is what we are trying to create. So this is like the CPU array, and the CPU array has these characters. Now the user or the player's array has the exact same size, but the difference is that his array is empty, or it is filled with dashes, and we need to, like, each time the user enters the character, be it wrong or right, we are going to display this array. But if this character is right, it's going to be stored in whatsoever index, but if it is not, then it's not going to be stored in that index. So the first thing we want the user to do is tell us the index, and then he later on tells us the characters. So let's go ahead. So here you could create a procedure to define the rules, but I'm not going to do that. But it's a nice thing to do, since it does tell the user or the player the rules. Or you could always just write the rules down here, and I'm not going to do that either. So we want to fill in the CPU's array 1 to 7. Assignment operator. So a character is simply like a letter, like just a character. That's exactly what it is. And we also want to fill in the player's array with dashes from 1 to 7. We want to assign player at the index of I, empty space. Oh, this is supposed to be in single quotes since it's a single letter, but anyhow, that wouldn't bother us. Now we want to set game, which is a boolean, to true. Notice here that we are not putting the true inside quotes, simply because it's a boolean. Actually, in this case, putting it in quotes would make it wrong. Now we want to set the win condition to be equals to 1. and we want to set the loss condition to also be equals to 1. So how would it work? Okay, let's go on. Now we want to use the while loop, while game, just like we did in the previous tutorial. If you haven't watched this, or if you don't understand why we are doing it this way, you should go back to where we spoke of control structures under the while loop, and you should get your answer there. Enter index. Well, just for those who don't get it, I feel like I should link the video below. So yeah, you will get the link below. So read, this index is the number where this letter is going to be saved, and I did not define this index. Okay, let's define the index. Sorry about that, but well, we do have space there, so at least I did spoke of the index. So we want to read and want to write enter character. So we want to read the character into the player's array at the index the player entered. So maybe the player is saying here, maybe the index is 2, so we want to store whatsoever value the player enters at this index. So that's kind of what we are trying to do here. Now that we've read it, the first thing we want to check is if the CPU's data, if CPU at the index of I is equal to player at the index of I, then we want to display message something like you got it right, or you got it, you got it. Right, now we want to count the number of like you got it the user got. Okay, the next thing we want to do is we want to check and else it means he didn't get it right. So we want to multiply the value which was here. So player at the index of I should be modified back to a dash. And you missed it. We want to write something like missed it. Now out of our if statement, we want to display our array for I from 1 to 7. Do right player the index of I. And here we want to end the for as well. Now we want to check the win condition. If count equals to 7, then we want to set right congratulations, you got it all right, you got it all right. and we want to set game to be false such that the loop can break because the guy has won. Oh, and if it wasn't count, it was win, right? Sorry about that. I defined the variable as win and I used count. Like this is weird because here I defined it as win, but later on during the algorithm, somewhere around here, I use count instead of win. Okay, so that needs to be swapped. Either you swap these to win or you swap these to count, but I don't know, that's left to you. Mine will be win, so I'm taking away this count. If win equals 7, then game false. And if so, we want to check the losing condition. If loss equal 6, because they said give them 6 trials, then write you lost. And we want to set game to be equals to false. Well, here we are using 7 simply because the size of our array is 7. So if your size of your array was n, you would use n here. And I'm really sorry about this mistake, and it's kind of disgusting to look at, I know. And we want to end if, and in essence that's our code. So this is the winning condition, this is the winning condition, this is the loss condition. I feel like there is something we need to update here. So in this part of the code, right down here where you say you missed it, we did not modify loss. Loss is supposed to be loss plus 1. So that's one more thing we didn't modify in the code. And we want to end our code. Now this code should work properly, but it has an error. Yes, an error I created on my own. Well, the first 2 errors I did not create them on my own, but I did create this last one on my own because I wanted to test those who were actually following the video. And I would like to see a comment. I would like to see the right answer commented below. So you see this value called count. I just don't want to change it to win because it was really disgusting, but it says it is win. So you see this variable called count, right? Now what will happen if the user finds the value at index of I? Let's say this is his array and all of these other places is empty, but he knows that at this particular place there's an O. So he puts in the O. It's right? So the computer counts it as 1. And he puts in the O again in that same index. The computer doesn't know, so he counts it as 2. It puts in that same O, 3, and it puts in that O up to 6 times, and the array is full. We don't want that happening, do we? So I wanted you guys to repair this problem. And thanks for watching. If the videos really help you, please leave a like and a subscribe, because I'm going to be dropping more videos on programming this time around and not algorithm. Unless you guys have an algorithm you like me to write, I would love to hear from you guys. So yeah, that's at the end for the video. So please give this video a thumbs up and help me help others. Thanks for watching.